Hello, everyone. Welcome to today's live stream. We're live on Facebook and YouTube. And today we're going to talk a little bit about paging and ambient noise compensation on the AHM64.
Hey,
And today
Martijn, I
with
think
me
we have
is
just another
Samantha.
second before we kick off.
And Samantha, how are
I
you?
think we have just, I'm doing well, but I think we have another second. We're not live yet. So
We're live yet. So
we've
we're
kicked it
streaming.
off, but it's not actually published yet. So I'm waiting for Val will give us the go ahead. All right, now we're good to go.
So then again, I think we had some technical ones. Welcome today to live stream on Facebook and YouTube. Today we're going to talk a little bit about AHM64 and then especially on paging and ambient noise compensation. Today with us is Samantha.
Hi,
Hello, Samantha. How are you?
I'm doing well this morning.
Okay.
It's 9 a.m. here. How are you? It's the afternoon.
Well,
You're nearly done.
we're nearly done. So yeah, we're doing good here. So Samantha, do you want to do the quick introduction on what we're going to talk about today?
Sure. Okay. So, just kind of like the title it said, today we're going to be talking about paging and ambient noise compensation. We're calling it, turning the page, as it were. So, just to give you a little bit of an outline of what we're going over today, a church is updating their campus audio. We'll tell you a little bit about the scenario. We'll talk about the technology that we are implementing. Then we'll dive a little bit into the end user experience, which many of us know is kind of the most important part of any installation or any AV work is how the end user interacts with the technology. And then we'll go into the programming of the technology itself.
Good one. So we have created an example, and that example is a church. And as you are a sort of expert on the churches, please
Seems
tell
it.
us.
Yeah. So this is going to be, at least for the Americas, probably about a mid-sized church. We're thinking this is probably about 400 members if you kind of base it off of that. But in essence, this is a nice little draft of kind of what the campus looks like. We've got 5 adult classrooms. We have 4 children's classrooms. We have a cry room. And for those that are not in America or don't know what a cry room is, it is actually what it sounds like. It's a room for crying, just mostly for children.
Okay.
So when you have a baby or a toddler that is just not having a good day, you are able to take them into a cry room, which is usually, as you can see in the diagram here, it's actually in the back of the sanctuary, and you're able to soothe the child, the baby, yep, perfect, without interrupting the service, but you're still able to either see through a window or over a video screen, see the service, enjoy it, but not disrupt it so that it's, everybody else's day is also ruined. So there's a cry
It's not
room.
for me. It's not for me when I'm having a bad day.
I mean, if you really need it, you go ahead and
Okay.
you go to
Okay.
the cry room.
Okay.
There's also a dressing room or a green room for the musicians and anybody else involved. There's a cafe, which is very popular these days in houses of worship. And we have a narthex or like a lobby area. And then we have the sanctuary itself where the worship is taking place. But some of the requested features of this church, as an example, this was actually derived from some projects that I've helped build over the last few months. But they want to be able to page different areas. They want an adaptive cry room, which we'll talk more about, an adaptive congregation area, local volume control, and they want to be able to have an engineerless service. So in case the pastor or the minister or a staff leader wants to be able to use the sound system or be able to have access to the AV, but not have to have a sound engineer there, we want them to have that kind of access to it. So that's a good kind of bird's eye view.
Cool. So we have a lot of inputs and outputs. Do you want to go over a few of them?
Yeah, sure. And you can kind of see, I love this diagram that Martijn made. So on the left-hand side, is all of our inputs, everything that we're kind of taking from the campus that we want to send someplace else. So you'll see we've got a sanctuary mix left and right. We have house music. We've got a broadcast feed, but we've also got feeds from the kids' rooms or paging mics from front of house and the narthex, as well as ambient microphones as well. And then on the right-hand side, we've got our outputs, everything or every destination we want to kind of cover. So it may be the main PA in the sanctuary, or balconies, or the adult classrooms, or a hearing loop, or the cry room, like we had talked about, or even the cafe, all these different kinds of places we want to send audio.
Yeah, cool. So in this case, we also want to page to all the areas. For example, the dressing room needs a paging from front of house or from narthex to do a start show. But in the meanwhile, they also need feedback from the sanctuary itself to hear where they are, right? So it needs to be a sort of mixed thing.
Right, exactly. Yeah, paging can be really helpful if you just need to get a message to another part. And for those that aren't familiar with paging, that's sort of, exactly it is being able to be in the cafe or at front of house and being able to page back to the dressing room that something is changing or something's happening without, blasting it over the entire PA, that kind of deal.
Yeah, nice one. Okay, cool. So that's also something we want to do. Then we of course have the sanctuary mix, which some of us see as the most important mix, which then feeds into all the PA outputs, which we also would like to control by volunteers or not even there. And we also want to send a feed, of course, to the cafe. So people who are late, don't want to interrupt the service, can walk in. Dressing rooms, we just talked about it. People need to know where they are. And then we also have a broadcast feeds, but in some cases, how do we do that? Feeding a sanctuary, the main board left, right to a broadcast feeds. Is that enough, or do we need more?
Yeah, sometimes, well, there's a couple of reasons you may want to feed the main PA over to the broadcast room or the broadcast feed. It may be that there is either not a broadcast mixer. So sometimes you just have to take that left right or version of the left right feed and send it out to broadcast so you can stream or record it. Sometimes you need to do that, and that option is always good to have. But then other times you may just want to feed that sanctuary mix like to the broadcast room itself so that the broadcast folks can hear what's going on and hear what's happening without having to necessarily, it's always nice to have a visual feedback in the broadcast room, but that's not always possible. So
cool. Okay, that's nice. Hey, and then equipment wise, we have some hardware and some not hardware. What's not hardware? Tell me.
Yeah, I said not hardware because it's not exactly software. Anyways, we'll get into it. But yeah, some of the equipment we've got, and we'll dive into these just a little bit. So anything that doesn't seem familiar, we'll get to. But essentially, for this kind of scenario that we're kind of propping up here, it's going to be, we're using an AHM64, an IP1 controller, and additionally an IP6 if you'd like to use that, and our Dante breakouts. And as far as our not hardware, we'll be using System Manager, which is the software that you actually use to control and program the AHM64. And we'll be using Custom Control, which we'll dive into a little bit more, as well as Dante.
Cool. So and all the software tools, we use them inside the tools that are available in the AHM64. Mm-hmm. So hardware-wise, AHM64 looks like a big beast. It is a big beast. We have 64 inputs, 64 outputs, or full processing, which people always say, well, that's too big for me. In that case, you only have 12 analog inputs and 12 analog outputs. And of course, you can add more to that one. We have Dante devices. We have an Everything I/O device, so we can open it up. It's the same ultra low latency core that we are also using inside the D-Live, the SQ, and Avantis. So analog in to analog out is under 0.7 milliseconds of latency. So connection-wise, we have those 12 analog I/O. And the nice thing about this one is that we use the same preamps and converters from our mixer family. So you have high-quality mic line inputs on the input side. You also have high-quality outputs on the output side.
With relays, as I recall, right?
with
So,
relay. So you can switch. I always get the question, why does my PA pop when I pull out my mixer? Back in the old days, we learned that you first have to turn off your speakers before you turn off your mixer. Nowadays, people are used to just unplugging everything. So in this case, we added relays to the output, so you can power this one down or unplug it without getting very loud pops on your PA system. I
yes.
still disagree on that way of doing it, but we are capable of doing it.
It's good to have as a whoops, I forgot, or the new person
Yeah, yeah.
ripped out the cable.
And a nice thing to know, that being said, there is a nice little feature inside the AHM, which when on power up, you can let it recall a specific preset. So if there is panic, you can always tell the person inside the building, unplug the unit, plug it in again, and then it recalls a preset and the device is in a state it is in where you left it. So
Yeah,
that in
excellent
that
point.
case, yeah. So we have an I/O port which can do up to 128 by 128 channels of audio on 96K. The Dante card does 64 channels on 48 or 96. And the upcoming S-Link card, where we need version 1.24, can do 128 by 128 channels at 96K. And of course, we have our S-Link port, which is built in. We can use our everything I/O unit. So all the I/O boxes with AB, AR, DX, GX will
Mm-hmm.
automatically connect to this port. And there's a 2x2 local GPIO. And one thing we've missed was the network port, which you can connect to all your IP controllers, your external
Of course,
controllers.
you got to have the network for it. It's
You got to
almost
have a network port.
implied.
Yeah. And the cool thing about this one is that if you have a Dante card inside, you can choose to have those three networks separately. Where on some devices you have to run all those things to the same network port outside. And here you can choose to have them all on one network or on three different networks. So a lot of I/O on the back. Let's go to IP controllers.
Yeah, so our IP controllers are I think they're just like beautiful and very sleek, period. And obviously I'm biased, but they just function really well and they're very sturdy. So in essence, our IP controllers are tactile ways to control Avantis, a DLive, or AHM64 in this case. So we actually have three models. One that's not listed here is one with motorized faders called the IP8. But for this example, we wanted to focus on the IP1 and the IP6. So the IP1, in essence, basically has two functions. It's a push and turn rotary. It is run over TCP/IP and it's PoE compliant, which is really big. But the biggest note I want to make is that you can have up to 64 of these on a single AHM. And then if we look at the IP6, it's almost like six IP1s in one unit, plus 19 additional programmable buttons. So not only do you have the regular rotary, but you can push and turn the rotary as well. Then you've got 19 programmable buttons. It's still PoE compliant and it still runs over TCP/IP. And you can have up to 16 in an AHM in addition to the 64 of the IP1s.
Yeah, correct.
So we'll be using these to program and we'll show you guys exactly how we're breaking that down. But speaking of breaking things and breakouts, Martijn.
Oh, Dante. Oh, you allow me to tell this. So our new Dante boxes. I'm really happy with these ones. They're going to be out there in the wild soon. Small boxes, DI size, two outs, two mic line ins, and a box with two mic line ins and two line outs. They're all powered by PoE, and they're all set and forget boxes. They can run at 48 or 96. So if you want to have high quality audio, you can use these small boxes on an end of a Cat5 cable without having to run an extra power cable and use them. It's excellent. For example, in this project, we have a few paging microphones, or we have some small speakers which maybe are not Dante enabled. Then we can simply,
like remote classrooms, things like that.
And we can simply run one Cat5 cable. If we're a bit lucky, we can use the in-house infrastructure. If the IT manager is capable enough of configure in VLANs, which most of them are. We can use the in-house switches and the network structure to use these boxes. So really cool stuff to work around with.
Yeah, that's also a great point, Martijn, that I didn't even mention on the IP controllers, is that because it's TCP/IP, like it's easy to just put them on the already existing network. It's not a big headache. They're addressed via IP, so it's piece of cake, plug and play. That's really how we prefer to do things.
Yeah. They're all layer 3 controllers. The same with Dante, it's also layer 3, so easy switching. And custom controls, Samantha.
Yeah, so a custom control, for those of you that have not heard it, is a free application that we make that allows you to create your own applications on Mac OS, on Windows, on Android devices, and on iOS devices. It's a way to create branded content or really accessible control over the AV system. And it works with HM64, of course. We couldn't bring it up here if it didn't work. HM64, but also DLive and Avantis. And it's a way for us, again, to create something that looks good and is really, really functional to interact with, especially people who, if our IP controllers are very tactile controls, some people just love touch screens or being able to bring their own phone and scan a QR code and be able to download this app and control the AV system. They don't need to have extensive training. It's easy to use. So we'll show you a little bit about custom control. So on the screen here on the left, we have the custom control editor, which is how you actually build the application. And when you build these apps, they actually live on the unit. So if we're creating an application for HM64, it lives on the HM64. We don't need to worry about having it saved someplace, or it doesn't need to be downloaded and other than just the application itself when you're running it on a separate device. It's really nice because then I can also plug in any laptop and I can go connect to my HM64 and look at that exact application that they have uploaded. I don't need to worry about somebody losing it someplace. I can just take it right from the unit. And then on the right-hand side is that login page for the custom control app. That's what you see when you're trying to log in to access a particular device. So you see DLive listed there, the mix rack. So you're able to just enter in, log in, and have access to the application.
So what Samantha already said, custom control works in a very cool and I think unique way where you have your physical audio DSP, which can be an AHM64, Avantis, or a DLive, and you use custom control editor to make your custom layout. It's all drop-down menus. You can drag and drop. What you see is what you get. Layout editor. Then when the user walks in, they can simply take their device, and depending on the user credentials, what kind of device they're having, which presets is active in the audio DSP, or which orientation even, the DSP sends the configuration to the custom control app, so to the end user. So the only thing the end user needs is to download the custom control app, and they need their user
Which is also free.
Which is also free, and runs on Android, Mac, iOS, Mac, and PC. You can make up to 256 different layouts inside the audio DSP, so you can provide anything you want. I've seen a nice layout where an end user has used their device in this way, and then they're all having faders, and then when they move it around, it turns into buttons. And it's not it's not the physical layout on the device. No, there is a completely new device being pushed to the end user, and the end user probably won't even notice.
Right. It's beautiful. I love doing that way, especially with phones, so you can really take advantage of the screen real estate as it's being presented.
Yeah, that's a really nice feature. So for this example, we have taken the layout from the church, and we added a few buttons on the bottom. And then when an end user presses in a section, it activates the paging for that session. So this can be used in a narthex where somebody's behind the desk, and they can simply really quickly talk to each specific zone.
Yeah, absolutely. Like if they wanted to quickly page all the children's classrooms and say, hey, Jimmy's mom's here to pick him up, go ahead and send him forward, or we can ping the adult classrooms, or even talk to, again, the dressing rooms if we need to. It just easily selecting them and hitting talk.
Yeah. Or if they're crying too loud in the cry room, right?
Yeah. Hey,
Could
keep it
also
down
be
in
one.
there. Yeah.
So it's an easy way. So this is really easy to build because the buttons in those sections are just simple plain buttons with a text overlay. So you will only see this when you don't use them, and when you press something, they become active. So IP6.
Yeah, so I wanted to show this. So you could use an IP6 for numerous reasons that could truly be a webinar all in itself. But for this example, I wanted to show what paging looks like. So I've seen it on custom control, and we're going to show you what it looks like on an IP1, but on IP6, this is a little simulation of that of an IP6 inside of System Manager. So it basically allows us to assign a button to open up a page, so one specific input to a specific zone. You can even see when you activate the page, the button turns green, the words page light up. So I may have my sanctuary level assigned to the knobs, and I decide, okay, well, let's just make this the page to the sanctuary as well. I can easily just click on the button and assign page. And now when they click it, it opens it up and they're able to talk. And I've also got one on the broadcast board as well. So if they wanted to select that, they could easily just say, I want to page the broadcast, hitting the button, and it opens it up.
IP1.
Yeah, so this is the really fun one. This is where we start to get really into the power of the HM64. You called it a beast earlier, which it absolutely is. But we start getting these layers where we can start layering things together and adding a lot of complexity where we want it to. And a way to do that is with the IP1. So sometimes we want tactile control, but we don't want to put an IP6 in place. We can use an IP1, which fits inside of a single gang box. So a light switch, for those of you that don't know, can fit in there. It's nice and sleek, easy to use, but we still want them to be able to page people. So we'll go ahead and click, and I'll show you what it looks like to the end user when they want to page on an IP1. So they push the knob, they turn to choose their destination, they push to select, paging shows up in red, and then they can push to end the page as well. And it goes back to that kind of home page where they're, this is being the front of house booth in this example. Again, clicking it, they select who they want to page. It tells them they are paging and it's active, and they can end it.
Very simple way on an IP controller to automatically do this. And because you can change presets, you can do this for multiple devices or even disable this. So I think we had a quick one, System Manager, where we're going to take you quickly over the software of System Manager. And we're going to do that live, if I'm fully correct. So we have System Manager running here. Make it a bit bigger. And System Manager right now is offline. As you can see behind me, there is an AHM64 under the SQ, and that shows up as online. If you don't have a unit online, you can run an offline AHM64, and you can do almost everything except changing the IP address, adding users and stuff like that. Anything that's hardware related is limited to the offline version. But you can prep your shows, and even if you have an external controller like Crestron, Extron, Needs, Kramer, you can point the IP address from your controller to your PC, and the software will respond with the same commands as the AHM would do. So you can test stuff and you can do things. So if we connect,
you can do full programming, almost like I'm hesitant to give it a number, but it's definitely over 90% of your entire programming before you even have the AHM or any of the IP controllers or anything. You can get all of that pre-programmed.
Yeah, correct. So if I connect to the AHM64, it asks me for a name, and it will tell me the power status. So if I'm doing a remote login, I can see, hey, my power supply is okay. I don't have any DC power in, or I'm not running off DC power, and I can see the firmware versions. If you want to update or copy, in the previous menu, there is Updater. The firmware is packed with System Manager, so you can use it easy. So in the configure menu, I can set the unit to do input stereos, output stereos. I can make my speaker processing. I have up to 8 signal generators, so I can also use signal generators to create comfort noise or to use a pilot tone or to do stuff. And I, of course, can save my configuration and restore the configuration, which is quite important. I have my controller menu where I have my local GPIOs, unit level sensing, which I fancy a lot. Unit level sensing is a sort of internal GPIO, or GPI, I have to say, which looks at a signal of an in or outgoing or anywhere in the signal chain, a signal, and you can set an upper threshold and a lower threshold, and then it acts on the audio signal. So you can turn audio into logic if you want to. And of course, we have our IP1s, IP6, IP8 controllers, which we can use. We have all our audio I/O ports. We have our users, so up to 32 different users, which we can set to active. And the neat thing is that the external control for any external controller can be disabled, can be plain without any security, or we can add an SSL certificate to do secure connection to from the controller to the AHM64. Then in Manage, I have my presets. I have over 500 presets. And the nice thing about the presets is that when I store a preset, the status of the whole device is being stored. And in my recall scope, I tell the unit what to recall for this specific preset. So I can, for example, only take my input and I'm my input 1 and only recall the Parametric EQ. So in this case, I can layer presets, I can stack stuff, I can make stuff simple. If I only want to recall something for one zone, I can easily do this. If I made a mistake, I don't have to worry. Everything is being stored anyway, so recall is easy.
Yeah, so you can always go back later and change your recall scope without having to restore this preset itself.
Yeah, correct. Completely correct. And even when I store the preset and I didn't want to, I even have an undo recall. So it takes me back to the state I was in before I pressed save or pressed recall.
Beautiful.
Then on preset recalls, I can trigger an external IP control. So on UDP or TCP, I can send out a hex, decimal, or a string to another device to start a projector or whatever. Crossfades, I have 2.7 gigabytes of internal memory for audio files, WAV, FLAC, and MP3 files. And they can be played back from the device itself. And I have events. And events allow you to trigger a playback or a preset on a specific time, on a specific day. So it makes it easy to, for example, in the sanctuary, every Sunday morning, 9 a.m., the session is starting. Or if I'm
go back to like a safety scene or something like that, or if something were to go wrong, it always, every week Friday at 8 a.m., it resets.
Good to go. Yeah. So that's a nice one. Then, of course, you have your input channels. So 64 input channels with full processing. I'm not going to go over everything, but you have an 8-band Parametric EQ. You have a compressor. You have 682 seconds of input delay on each input and each output. There are 64 channels of automatic mic mixers on board, which can be split up into 8 automatic mic mixers. So it's quite powerful on the input side. On the output side, you have your source selector, so you can set your IP controller. You have 2 priority inputs, which is also quite interesting. So if you're running in a zone, you can use priority input 2 for a priority for that specific zone. So if you take a microphone, somebody starts talking into priority 2, it will automatically dim the whole zone. And then you can
thinking of like a paging scenario, which is what we're really talking about today, or even like evac stuff, emergency announcements, that kind of stuff.
Yeah, and if you're saying evac, you can use priority 1 as an evac. So evac will also overrule your priority, your announcements and stuff like that. So you always have a 2-layer of security there. Then the cool thing on the output is that you have a 8-band Parametric EQ. And for the diehards, you still have a graphic EQ available. And if you really want to make use of all the parametric filters you can have another 8. So in total, 16 Parametric EQ filters on each output. Then each output has ambient noise compensation. We're going to tell you a little bit more on that one. And if you want to, you can have up to a 4-way speaker processing. So 2, 3, or 4-way. And then each output or output band has, again, full processing to the outputs. Control groups, so you can control specific groups of inputs, outputs on inputs, outputs, or cross points.
Yeah, like a DCA or a VCA.
Yeah, like a DCA.
If you're familiar with that phrasing.
Yeah, and then on your output patch bay, like on our live mixer, we have a very simple way. You just have your zones, and you can route your zones to any output on your device. So it makes it really simple, and you can simply click on items, or you can press and hold shift and quickly do a whole list. We can also make tie lines, which is quite a neat thing, where all the inputs, you can have 264 or 68 inputs on an ASMs and 268 on the outputs, but you can only process 64 of them. But what you can do is you can take a physical input into the AHM, then run it to the tie line patch bay, and then feed it back without processing to another output. So for example, you take something on a Dante input and you want to feed it to an analog output because there is something measuring. You can simply take that input, put it through a tie line, and then it doesn't need any processing inside the AHM. So which makes all connections, all the 268 times 268 connections available at the same time. Cross points, of course, so you can set your cross points. And one thing which I really like is monitoring. So you have a 31 band RTA, but where does it pick up the signal? So what you can do, you can open a second window, and that second window is on the same processor. And now when you hover over an object, it will automatically put those on the monitoring outputs on your device, or you can see them on your RTA. So for example,
it lets you know actually exactly where your pick point is right at the bottom, where your mouse is hovering at.
Yeah. So everywhere where your mouse is hovering, it will show you. Here you can see what the monitoring point is. It will show you where you are. And I did some videos on LinkedIn, I believe, which show you a little bit more. But now even remotely, you can see what is going on and where the signal is. So the signal stops here. And if I unmute it, the signal is still there. So you can quickly see where my signal is going and where it's stopping. So that's the software. Back to the PowerPoint.
Yes. So we'll kind of go back in our minds. We went over quickly about how all of our controllers show up in System Manager. But to give you a little bit of a recap of what Martijn just said about this section, each IP slot has its own programming. So remember, there's 64 slots for an IP1, and there's 16 each of the IP6 and the IP8. So there's one IP controller per slot, so it has its own programming, and the actual programming of that slot lives inside of the presets, of which we have 500. So in theory, I can use my presets to change the programming of a particular IP controller. So it's almost as if every IP slot has 500 available programmings because I may be changing it with every preset. And again, just note that we can have 64 slots per AHM. So if you have a multi-AHM setup, more than that, double that, triple that. So the IP1 connects with the AHM and actually retrieves the programming from that slot. So if we needed to, if something were to happen, somebody took a very heavy bat IP controller, we could easily swap it out and reassign it. It's as easy as unplugging it and plugging it back in, and it will still recall that programming so long as the IP address is correct. So gotta be careful about that.
Hey, and Samantha, what if the firmware on the IP1 is newer than the firmware on the install?
Well, luckily we have automatic firmware matching. So whenever we plug something in, be it our IP controllers or even our I/O, the mainframe, in this case the HM64, actually announces what it is. It asks what the connecting peripheral is. And if it's not matched, it either up or downgrades the firmware so that they're always matching all of the time.
Yeah. So if something goes wrong with an IP controller, we can simply take a new IP controller. And in this case, there is a really nice trick built into the IP, all the IP controllers, where there's a web server built in. So you can change the name and the IP address of the IP controller. And when the IP controller does not has received a configuration, it will show the IP address. So you can simply take a web browser. If you have changed the IP address and name of your IP controller, you can simply send it to the location. And at the moment it connects, it will check firmware and then retrieves the right configuration from the slot in the AHM64, and the IP1 will start working. Right?
Mm-hmm.
So that's a nice thing to remember, that the configuration is stored inside the AHM. Same with custom control. So all the hardware devices around it, they don't need extra configuration on which configuration file was in there. It just starts working. Then normally we do a behind the scenes, but today we're doing behind the presets.
Yeah, since they're called presets, now it's behind the presets. I thought I was quite clever with that. That's fine. So let's kind of take a look. So I showed you that we showed you that video of what it looks like when somebody walks up to the IP1 and they want a page with it. In essence, this is what happens. They press the button, the page becomes active, they talk, and they can return back to the default or a muted state. So now, if we're kind of looking, so the user pushes it, and the rest can be automated if we want. We can add some kind of manual additions to it, which we will talk about, but that's kind of the general idea. Then, if we really break it down, it is actually, so they push the button, it's actually recalling a preset, and that preset is going to change the routing and change the IP1 layout. Then we can use level sensing and embedded recall to automate or look for changes while they're talking or when they're done talking. And we can automate a change routing again and changing the IP layout back to its original state, just as if they just walked up to the IP1. So that's kind of the logic of what's happening behind it. But now we're going to show you how that actually happens. So again, we've got 500 presets available on the AHM. And as Martijn kind of mentioned, we can do commands or changes as granular as just the naming of one channel to changing everything about the entire system, depending on how we use the recall scope. So I've got a screenshot here of the programming that I have done for a couple of IP1s. So you can see presets 5 and presets 12, I've actually kind of labeled what they are controlling so that I always know, and we have a nice comments section on each preset so I know exactly what's happening when I click this, why did I do it this way. It's always good to have notes, folks. So all right, so presets 6, 7, and 8 activate the page to their listed destination, whether it be to the stage, the dressing, or to a full campus, and that is the front of house page. As a bonus, I added preset 10, which can manually end the page. And then same kind of deal, presets 13 through 18 will activate the page to those areas. And preset 12 is its default state. And then the preset 20, the little bonus one, is I want to end the page manually and go back to my default state, my mute. And we'll show you guys here. So this is a preset 7, and it's essentially going to activate the page to the dressing room. And you can see there, if we click, I'll even highlight it for you, that becomes unmuted when that is activated. And then, so it unmutes the cross point from the front of house page mic to the dressing room. And then, as the little yellow triangle changes, we're actually going to change the IP, the input name, excuse me, they change the input name and change the input color. So instead of being page front of house white for our organization, we're actually going to change it momentarily to paging in red so that on the IP controller, they know that this page is live. And Martijn did a great job of showing that recall scope, but here's a nice little zoomed in version of it, of us being able, all the different options we've got of being able to pick and choose what we'd like. So we've got input mixing. I can change just my unit GPIO or just my unit preamps if I'd like. I can change my patch bay. I've even got a couple of extra ones labeled under other. There's so many different ways, again, so granular or so massive. So Martijn, why don't you kind of explain a little bit about what exactly is in the recall scope? I feel like I've been talking a lot. So
that's no worries, no worries. You're doing well talking. So Samantha just told you what these are the groups of the blocks of what you can set for your recall scope. And when you select just a block, it on the bottom it will show you what it can do. So in our case, we do a name and color changing to red on paging. So that's input processing. So we only do channel 15, which is labeled on the IP1, and we're going to change the name and color in this preset because we want it to go to red and it needs to say paging. Then on the next stage, we want to do a crosspoint, unmute page front of house.
And this is all on the same preset, just to know this. These are all the 3 changes that are happening on this single recall, preset 7 dressing.
And now we want to unmute page front of house to dressing. So again, page front of house. The only thing we're changing is the mute to zone 41. And remember that everything which is not, I have to be careful with saying white or gray, but everything that's not highlighted will not be affected. So if I make any changes anywhere and it's not highlighted, it will not change. It will just stay as it is.
Yes, it stays exactly as whatever it was last doing.
Yeah, correct. And then the last one, on the IP controllers, I want to change the state of the controller. And you can see how granular it gets. On all the IP1s, you can even, one IP1, change the configuration of physically one unit. And if you have multiple connected, it won't affect the rest. So this is when you press the button, it recalls preset 7, the dressing room, and it changes the whole state of the IP1, and it's going further. So again,
this is how that looks.
Yeah, this is how it looks. You now know what happens in the background. So when I hit the button, sorry, should start something, right?
It should.
Wow.
Unless it doesn't. That's okay.
Oh, we have it. It should do something. It's not. Oh, here we go.
Oh, there's a little play button. All right. So yeah, push the knob, turn to choose your destination. Remember, it's turning red and says paging, and we push to end. So now you've seen what it looks like, how it breaks down in the background, and again, how it looks to the end user.
Yeah, correct. So the emergency handbrake, this is your trick. So please explain.
This is fun. You said that this was one of your favorite pieces about the HM64, right? It's just very fun. So we've got 10 programmable unit level sensing blocks. And we can essentially, we could always use our presets to change those. Everyone say, well, whatever, 10 times 500 for different unit level sensing blocks. But in this case, the logic behind it is essentially, I want to listen to a signal, and when it either goes above or below a threshold that I set, I want something to happen. I want to trigger something. So for this, when page front of house, which is that input, audio drops below the threshold that I've set for 2.5 seconds, and I think if you'll click it, we'll actually highlight it here so you can see it, see exactly where I'm talking about. When it drops below that threshold, it will actually recall that default mute state. We can click again and bring that up. And it goes straight to that end one that I've made. So it goes right back to that default mute state. Just in case, again, I like the idea of having it be an emergency handbrake. So if somebody were to not manually end the page, at least it can look and say, hey, somebody walked away or they're not talking, for 5 seconds, I want to go ahead and be able to say, all right, they've walked away. Let's go back to the default state.
Yeah, but what if you're in a noisy environment and the threshold stays there? So we got loads of noise in the cry room now. How are we going to solve that one?
Well, gosh, I imagine we could probably use embedded recall.
So what's embedded recall, Samantha?
Yeah, so embedded recall is a way to essentially kind of layer preset triggers. So on this screenshot, I've actually told it to wait. When I recall a preset that I have embedded recall on, I want you to wait 1 second, and then I want you to recall page preset number 5, which is page zone 1. And I can also layer these together. On the next slide, I've actually got one I want to point out. So we've got, you see those little, that little icon, the green circle with 3 play buttons on it. That means that there's embedded recall planted on it. And you can even see we've got this video going. We have got videos in this in this presentation. So when they select it, they can go and click, I want to page the stage. And then when they click end, it's actually triggering that preset, and then it waits 1 second, and then it goes right back to front of house page, its default mute state. It's a way to add automation to what we're doing.
Yeah, and the nice thing is that embedded recalls work inside a unit, but they also work outside of the unit. So you can also do an embedded recall on another AHM, or if I'm correct, also on another Avantis. So you can do a preset recall on one device, and then at the same time or in a different time trigger preset recalls on different devices. So it's a powerful tool.
Yeah, and to the example we said, like, oh, well, what if there's too much noise and they have forgot to manually end it? On each of those paging presets, we could have embedded recall to say, okay, if 1 minute passes or 2 minutes pass and they don't close it and nobody ends it and it's too loud to trigger the unit level sensing, we can just say, okay, well, automatically just boot back to the default. Like, it's a page, nobody should be talking for 2 minutes or whatever, the amount of time you want to set. So.
Yeah, correct. So, ANC, automatic level adjustment on background noise, which is an interesting one. In this case, the cafe and the narthex, we want to make sure that the level is not too loud, but also not too soft. So we're using the cafe music into the cafe zone on this side, and we are using the ambience microphone in the cafe to control the output level of that zone. That's where ANC is for, but how does it work, and how can we set it up correctly?
Yeah, and it's a very fast example, just to like really piggyback off of what you just mentioned, is if in an narthex or a lobby or the cafe area where lots of people are coming and going, things can get really loud and they can get really quiet. So we want to automate. This is a sort of automation to say, okay, there's clearly a lot of noise happening. Let's adjust the output of this zone so that it always feels like it's at the same level.
Yeah, correct. So ambient noise compensation, you have 2 room speakers in an area. You have people talking, shouting, whatever you want. There's an ambient mic, and that picks up the noise of course, the speakers, but also the people inside there. So we want to make sure that the level goes up when the level in the room is high, or the level goes down when there's nobody in there, where everybody's quiet. I can imagine that everybody is sitting there being quiet, and there's an announcement at plus 12 dB. We're not going to see happy people. What we also have to be careful for is that we don't get into an infinitive loop where people get louder, the speakers get louder, and then the speakers also trigger the ambient microphone. And then the ambient microphone thinks, well, everything just got louder, so the speakers also need to get louder. And we sort of get into a loop where maximum is reached and we get confetti out of the speakers. So that's where we use gap metering for. And gap metering is a neat little trick where we measure in between the program material. So for example, when you're doing announcements, when there is an announcement, there is no level control on the output zone. But when there's no announcement or there's no music, the system starts measuring and automatically adjusts the music for it. So in the cafe, you have to make sure that there are small gaps, and those gaps can be a few seconds between the songs, so it can measure where it is. But this prevents the whole system from getting into a loop and making things louder and louder and louder. So the setup is fairly easy. you simply set your ambient level metering point, you set your gain differential, you set your gap metering and the time it takes to measure, and your threshold, so at which point it's starting to measure. And then you can say your controlled gain, which is your zone gain. You can set a minimum and a maximum gain to it, and the rate it goes up or down. Because in some cases you don't want the audience to hear it. But if you're, for example, on a racing track, you want this to be very quick, because if there's a car passing by, you want it loud. But if that car is gone, you want to drop it as soon as possible.
Mm-hmm.
So that's a little bit about ambient noise compensation and gap metering. This is just start playing with it and messing around with it. And if you keep that controlled gain low, the mistakes you can make are not that big. So it's fairly easy to learn.
Mm-hmm. Yeah, here's that same slide, kind of just giving you guys another overall of bird's eye view of this project. So it's a mid-sized church with lots of classrooms, different areas. They want to be able to page different areas from lots of different zones. And they want to have an adaptive cry room, an adaptive congregation area, and be able to have local volume control as well using those IP controllers. So I think we've come to a time now where we can see if any questions have popped in. I don't think I've seen any thus far, but let's open the floor.
Yeah, so if any of you have questions about this, please shoot, and we try to answer them. And I will also like to remind people that what Samantha and I are trying to do is to grab some projects, which can be projects which are already there. Maybe there's a project you want to start or you want to help on. Please drop in those questions or send those questions over, and we'll try to make them into a topic and see if we can help you out with specific questions or try to find a solution for what you are trying to do. I always say more minds make better solutions.
Of course. Oh my goodness. Yes, I love that. I'm going to steal that. That's great.
I also stole it, so we can steal it.
Perfect.
But so if you have any projects which you're looking forward to, please send them over and we can see if we can discuss them so everybody can learn from them. Do we have any questions from anyone who is watching? I don't see much questions coming in.
Yep. So far, that must mean we're blowing their minds, and the questions will come a little bit later.
Who knows? Well, if we don't have any questions, I think we sort of can see what's. We can simply wait for people.
Yeah, we can wait a couple seconds here. I know it takes a second to pop into where we're at, but
yeah. And let's see. Now we have a lot of people saying hi, and a lot of people.
Yeah, hi everybody.
Hi everybody. Hi back.
Okay.
I think we're going to end this for today.
Yeah,
Again,
force them to look at us.
I think that the comments stay open. And,
yes, I'll be looking. I'll log in and look and see if anybody's posted anything. Feel free to email or message us. So
yeah. So thank you for watching. Hopefully see you on the next one. I think we're going to do another one in a few more weeks. I have some different topics on this one. If you have nice projects, please let us know. And otherwise, see you on the next time.
Yeah. Thanks, guys. Bye.
Thank you very much. Bye-bye.